Hello guys, welcome to another edition of Blue Tech Empire Python tutorials. In these tutorials, we are going to be looking at Python basic operators, and particularly we are going to be looking at arithmetic operators. We all know arithmetic, the plus, minus, division and times, multiplication, and all these operators. So I believe this one is going to be an easy one for all of us. So let's dive directly into the video and look at a few things. Now we're gonna do some reading here. But before we do some reading, I would like to explain to you a few stuff. I'm going to exit this and CLS and I get back into Python. So one thing I want us to know about operators. What are operators? Operators themselves, are constructs which we can use, which can be used to manipulate the value of operands. So it may sound complicated. I know we are here for programming, not all this literature, but sometimes literature is very important. That's why you need to know some of this stuff. So what is a construct? A programming construct can be any character. When you type a character in the programming, for example, if or else, you can call that those construct or keyword or whatever. But we just call stuff. We say construct to mean a word in a programming language can be called a construct. Like you say words in English language, you can say and is or all these words. These are all words in English language. In programming language, you can simply call them construct or characters. For example, the plus is a construct. The plus is a construct. The minus sign is a construct. The division sign is also a construct. So when we say operators can be a construct which can be used to manipulate the values of operands. Now you start getting the point. Operators are constructs. So for example, if we have var1 equals to 30 plus 55.5. Now, we are calling this a construct and we are calling these operands. But in this case, these are literal operands. We call them literal because the values are typed directly in code. So they are like, we call them literals. Now let's have real operands. All right, so let's say A equals to 30 and B equals to 45.5, and we say C equal to 30 plus 40 C equals to A plus B. Now we can now clearly say the operator, which is a plus in this case, the addition operator, it's a construct which can be used to manipulate the value of its operands. Now its operands are A and B. Now it has two operands, so it's known as a binary operator. Now a binary operator has a left operand, in this case A, and it has a right operand. Now this is a left operand and this is a right operand. Now we see this operator actually has two operands, so it's called binary. When we talk about binary, we're talking about two operands. So I want you to understand that. So we have different kinds of operators. For example, we have unary operators. In the case of unary operators, like if you have let's say B equals to true, or let's say let's just say ends equals to true, and you say not ends, it returns false. Now you see not itself is an operator. It's a boolean, it's a we call it, right? So it can be a bitwise operator, or we can still call it's some form of a logical operator. But for now, let's just understand it as a bitwise operator. But the main thing I want to explain here is it's a unary operator. For example, it just has one operand and it's the right hand side. It has no second operand, so we call it a unary operator. When we talk about unary, this is what we mean. Now we also have a ternary operator. Now, when we talk about a ternary operator has three operands. For Python, I'm not very sure yet of the ternary operator. I think I haven't seen one yet. I haven't seen one yet. But in a language like C, we have ternary operators and binary operators. So for clarity, I'm going to show you an example. All right, so take a language like C, where you can say integer a equals to 10 and integer or float b equals to 40.5. Float float c equal to a plus b, and we say print f answer percentage f, then it's, let's say c. Let's see if this works. Let's end it here with c colon. Now let's see if this works. Sorry. um all right, it printed 50. We can make things simpler by just saying percentage dot 2 f. You don't need to worry, we aren't learning c here, so I'm just trying to show you an example. No c here. I just want to show you. All right, 50.50. All right, so here we see, here is a binary operator because it has two operands, a and b. Remember, this operand can be any identifier. It can even be literal operands, like we saw in the case where we had 10 and 15. Here we had 10, 30, and 50.5. Here are literal operands. But in this case now we have variables, a and b, which is more obvious. All right, so now let's see an example of a unary operand in C. I just want you to see. Now take for example, if you say C plus plus, it increments the value of C by 1. You see, it has only one operand, the left operand. We can even say plus plus C in another case. So let's see at every step. Let's print C. All right, so let's print C at every step. So you see, print F percentage. In fact, let this be all right, percentage dot 2f slash n. Let's print C at every step. Okay, so let me say 1. This is the first step, just so you see what's happening. All right, so now let's see. Here is the second step, and here is the third step. I just want you to see it's actually manipulating C. It's not just for fun. All right, we need the semicolon here. It's C. Need a semicolon here. I just forgot. Python gives us a bad habit about semicolons. All right, so here we have 1, 2, 3. So you see the value of C was actually incrementing from 1 to 2 to 3. All right, so percentage of 2f. Oh, say the 2f, percentage of 2f, percentage of 2f. So we have C float equals a plus b plus c. All right, so let's see again. All right, so it's cool now. 50.1, 50.50, 50.50, 51.50, and 52.50. All right, so now let's see what happened is C++ is incrementing C by 1. So I just want you to see here is a um here's what we call a unary operator. It has only one operand, and you see here it has a left-hand operand, while here is still a unary operator, but it has only a right-hand operand. Now, C has a certain operator called a ternary operator. You may not see it in other languages, but it's common in stuff like PHP and other. JavaScript has it, but I've not seen it in Python. I've not seen it in Python. So I guess Python may have a ternary operator, but I haven't seen one yet. So I just want to show you the ternary operator in C. So C has an operator which tests for a boolean. For example, we can say if 3 is, or let's just say let's use A and B. Let's say A, B. Let's say if A is greater than B. Here is, you see, I'm going to show you what happens. If A is greater than B, just say A greater than B is going to print this, print um yes, or print no. Don't know if it's gonna work. All right, so you see, it printed no because A is not greater than B. Now, if let's see, just so you see, it actually printed no. So let's see, you see, it printed no. Now, if let's reverse the sign. If A is less than B, print yes. You see, it's gonna print yes this time. So it printed yes. I just want to show you it works. Now, here is what we call in C, it's called a ternary operator. It has three operands. Here is the first operand, it's a Boolean expression. Here is the second operand, the value to be printed if this Boolean expression results to true. And here is the third operand, the value to be printed if this Boolean expression results to false. You don't need to worry about this. I just want to show you we also have ternary operators that have three operands, not just two, because you may not see it in Python. So I just thought I should show you in C. So let's get back to Python from where we came from. So you see here is it has just a single this one is a binary operator, has two operands. Here is we have a unary operator has a single unary operator not has a single right hand operand. So and so I want you to keep that and fully understand that. Now in the case where we have this C is equal to A plus B. Now you see execution, what happens is A plus B is first added and then the result is assigned to C. So here we have the assignment operator and here we have the addition operator. Now the execution of this expression is from right to left. Why? Because it does this first before doing the assignment. So this is gonna be it's similar to writing C equals to A plus B, that's 75.5 is the same. So this results to something like normally C 75.5 is still the same as writing C equals to 75.5 because it adds A and B, it gets the result, then assign it to C. So this is called the assignment operator. So I just want to show you that what we call associativity. When you put operators together, for example, if you write C equals to 10 times 4 divided by 2 plus 3. You may sometimes want to know which operator applies first. Of course, everything here is going to be applied and calculated or computed before and the result will be assigned to C. But sometimes you may come across where you want to know, is it the multiplication, division, addition, which one occurs first? Is it 4 divided by 2 first computes and adds 3, you want to know. So normally, you know from board maths, if you've done mathematics, you know division is first and bracket of division, multiplication. So maybe you can have division first and multiplication, then now the result now here will be added to 3. But we are going to learn this later. It's called operator associativity or operator um, precedence. Precedence normally. So that's where you actually know how which operator has a higher precedence than another operator. In this case, division has the highest precedence. So 4 divided by 2 will first be evaluated, and normally the result is 2. Then you're going to have 10 times the result, which is 10 times 2, which is 20. Now 20 plus 3. So this should give you 23. This should give you 23. So that's it. So, but it's I just want you to understand it's different if they added two first, then all those stuff. So I just want you to know we are going to learn that later. It's called operator precedence, and whether expressions are evaluated from left to right or right to left is known as operator associativity. We are going to see all that in a later video. But for now, let's look at the different arithmetic operators. All right, so now moving to the different arithmetic operators, we have the addition operator. Very easy. We all know 2 plus 4 plus 6. We all know, 12 plus 4. We all know. So let's move to the next operator, subtraction operator, we know 12 minus 4. We can even say minus 4. You see, we can say A equals to minus 4, B equal to 6. You can say now A minus B. I think it should give us 10 or negative 10. That's A is minus 4. Okay, minus 4 minus 6. All right. So if we say B minus A, I think it should give us 10. Yeah, minus minus is positive. So you can do all this mathematics here. You can assign them to values, manipulate them. I believe these are very simple operators, so we should not have time. We also have the multiplication, which is just A times B, or A times 4, or 4 times 4. It's just like your calculator, so don't worry about, should not worry about this. Now I just want to throw in something here. If you have an expression that is too complicated, you can use brackets like you do with normal mathematics to separate stuff together. For example, you can say A equal to sorry A equal to 7 plus maybe B. I think we have B times 2 plus 3, 4 raised to the power of plus 4 minus 2. You can use brackets just like you do in mathematics. I want you to know that. So if you have a complicated expression and you don't know, you will not normally know. For example, if you write this like this, it's going to give you the wrong answer. If you write this like this without the brackets, you have a different answer. So it shows, if you're confused about how operators work or the precedence of operators, don't do like this. You understand? Because it gives you a different value and that value is wrong. This is what you actually wanted to do. So you can use brackets to actually organize your mathematical expression. We're going to see brackets has the highest precedence. So everything within the bracket, just like mathematics, will be computed first and the result now, and just like board math. So I just want you to know you can use bracket like you do in normal mathematics. You can also use it here in Python, you see, for your mathematical expression. So now let's look at another expression, subtraction, multiplication. Let's look at division. We already know division, it always returns a float. For example, 4 divided by 2. You should always know, if you use division, your answer will always be a float. Even if they are, for example, even 10 divided by 5, which is 2, is still a float. Let's check it. A equals to 10 divided by 2. Once you use division sign in Python, you get a float as a result. If you type A, you see float. So you just know that if you want an integer, then you have to do what we call floor division. I'll be showing you lately. Or you can check, for example, if it's an integer. For example, if you write um, A dot is integer, I think value or something like this. There's for example, let's check d of float. We're going to see it. This A dot is integer. All right, A dot is integer. Give it true because A was 2.0 and it's actually 2. So you can do that, but let's not worry about that. So what I want to also show you here is, if we have what we call floor division, if you know what you're doing is actually an integer division and you want to discard the negative sign, then you can use what we call floor division. That's two division sign. You see, it's extracting only the, and if you check, for example, A equals to 10 divided by 2, check type A, you see it gives you integer. So if you know you are not interested in the decimal point of any mathematical operation, even if you have 3 divided by 5 and you want is 0 point something, but you want to discard the decimal point, you use floor division. We call this floor division. In floor division, the decimal point is discarded. It's discarded far away. So here is floor. You can follow from here. Here is floor division. I just wanted to show you alongside division. So let's go to modulus. You know about modulus. A modulus B is the remainder when you divide A by B. Consider you have 4 items. I'm going to show you maybe on a board. All right, let's look for an eraser to erase this stuff. All right, pardon me. It's going to take us a lot of time to erase all this stuff. All right, so All right. So now let's say we have you have two people and you want to divide four items. You have, let's say you have five items. You have five items. For those who don't know modulus, I know most of you know modulus, so I'm just explaining to those who may not understand modulus very well. You have five items and you want to divide it to two people. Two people. Now you see, you take the first one. Let's cancel it. We divide it. We give this guy. We take the first one. Second one. We give this guy. We take the third one. We give this guy. And we take the fourth one. We give this guy. Now, they have equal. We can't give anybody anyone again. So what remains? We have one remaining. So it shows 5 modulus mode. We can say 5 mode. Normally, in normal mathematics, you divide these two and give everybody to have 2.5. But modulus, they must have equal. Once they have equal, then we can say there's a remainder, and the remainder is equal to 1. Let's see it in Python. If you type 5 modulus is the percentage sign 2, your answer is 1. I just want to show you how modulus work. And you obviously, you know, if you have 7 items and you divide it by 6 people, is going to be, or if you divide 7 items by 6 people, everybody is going to have 1 and it's going to remain 1. So it's going to be 5 6 modulus 6 7 modulus 6 is 1, because you're going to divide by everybody and all those stuff. Now 7 mod, let's say mod 3 will give you, if just, I'm just like in our imagination, if you have 3 stuff and you want to divide 7 by them, of course everybody is going to have 2 each, sorry, 1 2 3 4 5, maybe you have 5 6. So you see 1 is going to be left, so 7 modulus 3 is 1 and all that stuff. So I just want to show you modulus is the remainder when you divide something by something. A modulus, or let's say the modulus operand, is the remainder when you divide its left hand operand by its right hand operand. So we are saying x a, for example, let's say a equals to 10, b equals to 7. A modulus b means the remainder when you divide a by b. Now let's see, if you take 10 things and divide by 7 people, you see all the 7 people are going to have 1 1 1. True. Then you're going to have 3 items left. You can't divide that 3 items by 7 people, so it's going to be 3. So if you take let's say 11 stuff and divide by 6 people, so let's say 11 modulus 6, what's going to happen is each of them is going to have 2 2. No, let's see, 11 divided by 6, yes, each of them is going to have 1. Then you're going to have about 5. Let's check. Yeah, a remainder of 5. So that's the concept of remainder of this. Is very, very important. Modulus, this modulus operator is very important. You can use it to test if a number is a positive or a negative number. For example, let me show you a quick example here. Let's check. Let me show you a very quick example here. If we have something like a list of numbers like this: 1 2 3 4 5 6 6 and 7. Now we can, if you want, let's say this equal to L1. Now L1 is equal to this. Let's say we want to print only odd numbers. Every odd number modulus 2 is 0. If you take any odd number, any even number, sorry, and divide by 2 people, you're going to have a remainder of 0, because all of them are going to have equal. So we can use it to test for odd or even number. For example, we can say for item in L1, if item mod 2 is equal to 0, it means it's even. I'm going to print it out. So you see, I'm going to only print out even numbers. I just want to show you. Now, it's very important for modulus. Yeah, you see, let's save this and run. I just want to like copy this stuff here. Pardon me. Uh, let's place this in script. So let's now save this stuff. Okay, so now let me save this so that I can now run it. Okay. Now you see we have 2, 4, 6. It printed only even numbers. How manage? Because we use the modulus operator to check. Okay. Now you can still use the modulus operator to keep running through the first, maybe the first items of it goes. You can use it to loop around a group of items. Yes, we're going to look at that later on. You can use the modulo sign to loop through a group of items and never pass the end. For example, maybe we want to loop through these items continuously. We can loop from index 0 to index 1, let me say 10 times. Let me show you how we're going to do it. So we can just say start equal to 0. We can say for while while start is while start, let's say, let's now count. Let's loop through the loop, let's say 20 times. Let's say 20. Let's say loop should be 20 times. So let's say while let's say count equal to 20. We can say now while count is less than 20. We can keep looping through those. We can keep printing the index from 0. So let's print print L1 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 start mode start mode mode 0 1 2 3 1 2 3 4 5 6 7. Okay, mode 7. So once you reach 7, it's going to go to 0 7. Yeah, so let's print something. Print this start mode 7. Then we're gonna say start plus equal to 1, and we're gonna say count plus equal to 1. Now let's see how it may do some funny stuff, but we're gonna see what's gonna happen. All right, so why? Okay, let's start. Count should start from 0. Sorry. Um, Now let's see what happened. You see, it printed. Let me put this up so that you see. I'm just trying to show you guys the. Now see what happens. What we are trying to do is we actually are we want to go through this loop 20 times. Each time we are going, we are using the index start, which was 0, mode 7. You understand? So now what we do is that the first time is start 0 mode 7 is 0. We will increment starts by 1, start plus equals to 1, count plus equals to 1. The next time is count less than 20. Yes, because we are incrementing count only by 1. Count is less than 20. So we are going to print start, which is now 1 mod 7. You understand? So so as you can see, here is our result. Now we go from 1 2 3 4 5 6 7. We start back from 1 2 3. You see how we print in 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. The reason is we are using mode 7. So the first time we print 0 mode 7, which is the item at point 0. If you have not learned this, maybe you can watch the list video to really understand what I'm doing here. So you see I print the index 0 because 0 mod 7 is 0. Later on, I print 1 mod 7, 2 mod 7, 3 mod 7, 4 mod 7, 5, up to 6. At the point where count reaches 7, where start reaches 7, I'm printing 7 mod 7, which will go back to 0. You understand? After I go to print 8 mod 7, which is 1, 9 mod 7 is 2, 10 more 7 is 3 until the point we did it until the point 20. But I'll just show you, you can use the percentage, this modulo stuff, to keep going round a set of numbers. So in this case, we are going round 0 to 6. 0 to 6, 0 to 6, 0 to 6. So we are having we are going around this stuff, even though start is increasing, but because you see we are incrementing start here by 1, so start is going ahead. But because we are using modulus, it cannot cross, you will never access more than the end of this list, you understand? So when you're writing some complex programs, you're gonna realize modulus can come in very, very handy. In fact, it's difficult to make a very complex program without doing something of this sort using the modulus operator. So I just wanted you to know that. All right, so let's go back to our note. um so in this case now, let's see, we have talked about modulus is the remainder when the left operand is divided by the right operand. Now we have exponent. Exponent is just raised to the power. So if you say 2 exponent 3 means 2 raised to the power 3. And remember, if you want to find the square root, you can say, for example, the square root of 16, we all know is 4, but we know square root actually means raised to the power half. So you're gonna write half inside here, and we know cube root means raised to the power 1/3, fourth root means raised to the power 1/5, sixth root means raised to the power 1/6. So whatever you want, you can do it. This 1/3. So this is 16, the cube root of 16. Let's find the cube root of, let's say, 8. It should give us 2. So let's find the cube root of 8. 8 should give us 2. Let's find the cube root of 4. Let's say 4 times 4 times 4. Okay, 64. Let's find the cube root of 64. 64 to the power 1/3. 64. You see, you give us 3 points. You understand? Python is not very good with numbers yet, but you can round it up. You can round this up if you want. Don't know if round is an inbuilt function. Let's see, 3.9999999. All right, it gives us 4. So you can simply round this stuff up to make life easy for you. So if you want, so just Pythons allow us to find cube roots, and because we're using the trick 1/3, we know it's 1/3, so it's still raised to the power, but we're using now 1/3. So just know square, if you're looking for the root, you can just simply say, for example, the square root, the root 4 raised to the power 2 is given by 4 star star 2, while the square root of 16 will be 16 raised to the power half. Those are for those interested in mathematics. If this is not your field, you can just forget about all this cube root and square root stuff. So those are the simple mathematical operations, or arithmetic operations, sorry, in Python. So let's see some examples here. So we have A, B, C, D, E. Now we have A plus B, which is var1. You see A minus B is var2. We said var2 should be C minus B, sorry. So it's still going to take C minus B. So we're going to print it here, and I think the result should be obvious. That's 8. Yeah. So we said var3 is C times A. Here we are using the multiplication operator. Here we use the multiplication. Here we use the multiplication. And you see we are assigning all the results to values. This is how we do in a script mode. In the interactive prompt, Python will just print results out if you don't assign them to a variable. So here we're assigning them to a variable so we can use them. For example, we use this within the print statement. So this var3 is just going to be the result of C times A. var4 is the result of A times 12. All this stuff says. So that should not be hard for you. Now, John is equals to 6 all over 3. These are literals, integer literals. Now we have Jude E over 4. So we see print John and on all this stuff. Now, rather we are using now floor division. Is going to neglect the decimal point from the division. Like I told you, when you use division in Python, what is returned is always a float. So you need, if you want to ignore the decimal point, because even 4 divided by 2 will give you 2.0. So you usually want to discard the decimal point. You use the floor division as 2 forward slash. Now you have out, we use the modulus. 12 modulus 4 should be 0 because 12 is an even number. Let's see, no, 3, 4, 8, 12. Yes, it should be 0. So E modulus A was E modulus A. 11 mod 2 should give us it should be equals to 1 because there's a remainder and it's 1 when you divide 11 by 2. Most odd numbers, once you divide them by 2, they always have a remainder of 1. All odd numbers. Now let's check, is it all odd numbers? Yes, I think all odd numbers. Yes. So let's look at this. Here is now raised to the power, raised to the power. So I just wanted you to see that. Very simple. We have a few results here, but we've already looked at that. So we have a few results here. You can check the result and match it with the code at your spare time. Now, note the difference. Here are the results. All right. So note the difference between the normal division and the floor division operator. With floor division, the fractional part or decimal point is discarded. So in the next video, we are going to be looking at Python comparison operator. It's very important. Comparison operator is what we use for the if statement, the while statement, that's conditional, and all these looping constructs. So see you in the next video, and have a nice time. All right.